Hello, and welcome to ProMind's webinar. Today, I'll be talking about rock mechanics. My name is Robin Montufar, and I'm a technical specialist here at ProMind. Thank you for joining us. So before we begin, I just want to go ahead and tell you a little bit about ProMind, who we are, what ProMind is, and what we offer. So ProMind is a company based in Canada, in the province of Quebec, and it was established back in 1993, and we offer software for mining industry, especially focused in mine design, survey, and geology. Our headquarters are in Quebec City, and you can contact us via telephone, fax, or email, and our website is promind.com. So the company is trusted by over 100 clients across North America, Central and South America, Africa, and in Europe. Our mission is to help our customers be more efficient and more profitable in just a few clicks. As I mentioned, ProMind is a software solution built for mining, survey, and geology experts. It's an extension of Autodesk AutoCAD software, and it provides additional functionality towards the mining industry needs. We have surveying tools, 3D modeling tools, geology tools, which fall under the ProGeox flag, and engineering tools. The software has 35 easy-to-use modules for mine design, planning, underground work, modeling, and design in survey, drilling, blasting, dilution, and other ones. Today, we'll be looking at the module on rock mechanics. It's a small module, so it shouldn't take us too long, maybe half an hour or a little bit more to take a look at it. The module allows to quickly insert the hydraulic radiuses into the openings of your mine or your mine design, so you can easily visualize the potential for problematic areas. It also allows you to compute the rock mass rating and the Q system of your rock. The module is made up of these icons, as you can see. There's 6 icons, but there's one of them. It's has extendable icon, has 3 more within it. So with that said, let's get right into the presentation. So just give me a second while I switch to AutoCAD. Okay, thank you. So as I mentioned, rock mechanics is one of the smaller modules. You'll find it under the engineering 2 tab. And I shifted mine, I moved mine, but normally you'll find it around here in the middle of the tab. I moved mine just for easy access. So right here at the top, we have our first command, the insert radiuses command. And this command allows to insert the hydraulic radiuses based on the input of the stop, pillar, and opening contours in your mine. What we're looking at here, it's a small drawing of a drift plan. It's one of our ProMind levels, one of the mine we use at ProMind, one of the levels at the ProMind mine. But actually, sorry, this is the one I want to use actually. This one's better. Same thing. It's one of the levels at the bromine mine. And I just want to mention that the hydraulic radius is not really the hydraulic radius that we're computing with this command, but the distance from the walls, these walls that are being measured, and we're going to make an average of the distance so that in the drawing we can give values to the strongest points of the ceiling of your mine, and we're going to indicate the weaker points in your ceiling. So just to illustrate how this is going to be computed, I have this image of how the computation takes place. We pick a spot from where we're going to be doing our measurements. In this case, I picked this one. And the program is going to compute the distance from here towards the walls, and then it's going to give us a value of a value that is going to be illustrated on our drawing. So I'll remove that and I'll run the command. Click on that. And like with most commands with ProMind, we get here at the bottom, we get a message asking us what to do. So it's asking us to select the stop contour polyline. In this case, I have my contour polyline here. As you can see, I've selected only this section. I could do the whole contour polyline for the drift, but we're only going to concentrate on the upper part. So I go ahead and I select the contour polyline. After that, the program is asking us to select the pillars polylines. I don't have any pillars, so I can just click enter. And next, it's asking us to select the opening polylines. Opening polylines refers to openings such as chimneys or the races, chimneys or races that you will put in your design. I don't have any of those either, so I'll click enter once again, and then we get this window. Here, the spacing is in reference to the spacing of the annotations that are going to be placed in the drawing. So we're doing a spacing of 1 meter. That should be enough. We could make it smaller, but 1 is a decent number. The text size is the text that's going to be placed in each square. And the precision, the degrees. This is in reference to the precision with which we want to make our measurements. I'll cancel that and I'll show you what I'm referring to. The precision refers to how close I want to be making the measurements. As you can see, each line here is separated by 10 degrees, so that I have the 36 measurements in total. I could make the precision every 5 degrees or every 25, whatever you want. In this case, I've done it every 10. So that's what it's in reference to. So I'll go back. And we'll keep it at 10. Now the maximum distance It's the maximum distance in which the radius is going to be calculated. So remember the image I just had, how the lines are radiating all over the drift. I've given it a maximum of 20 meters. You can do more than that, obviously, but if you were to do more than that, you'll be getting like farther down into your drift. And in this case, we want to stay just in this upper area. Okay, and the display value has to be greater than 1. And we'll apply the colors. So then we click OK. Then the program takes a few seconds to do the calculations. And there we have it. So as you can see, the values we have, the green lower values are closer to the wall. But as you go towards the middle, or the farther away from our wall, we have larger values, which indicates that our hydraulic values are higher here in the middle, obviously. So with this information, your geomechanics departments can mark this area in red, and they can decide if they want to add rock bolts, they want to add a higher density of rock bolts, maybe put some cables for support or support cables. It'll be up to the geomechanics department, but this is what the command is telling us, that here in the middle and up here, your hydraulic values are higher. So once you have these numbers, you can go ahead and make some contour lines to better visualize what we have. And that's where the next command comes into play. So we'll click on that. And once again, the program is asking us to select the objects. So we'll select all of them. And then we'll click enter. Our contour interval, I'm keeping it at 1, but if you wanted the contours to be more packed, more closer together, you could do like 0.5, or if you want less contour lines, you could do 1.5. We'll keep it at 1. And we give it a few seconds. And here we go. So you can see them as, you can visualize them almost as elevation contours. Here, the higher ones. And you can use these contours to decide about whether or not you want to add extra support in these red areas, as I mentioned before. Because as you can clearly see, there's more tension, the rock tension in this open areas, the farther away we get from the walls. So if I do want to show you how this changes when we add a pillar or some kind of support to the middle of our drift. So I'm gonna go ahead and erase this data, and that's where this command comes into play: erase hydraulic radiuses. So we'll click on that, and I'll erase all the annotations. And manually, I'll erase my contours. Okay, so if we had a small pillar in the middle of our drift, and now we go back and do this again. Once again, we select the stop contour polyline, but this time we have pillars, so we'll select them. We don't have any openings such as chimneys, so we'll just click enter. And we leave everything the same. Click OK, and give the program a few seconds to work. And voila, you can see that now the higher hydraulic values are gone here in the middle. And once again, it's just like closer to the walls, it's we have low values around our pillars. So that's the basics or the gist of the hydraulic hydraulic radiuses. Now we can take a look at the other commands, which are how to calculate the Q system and RMR. So for that, I'll switch to another drawing. And here we go. We're going to begin with the calculating the RMR, which stands for rock mass rating. And this computes the value which describes the rock stability. It's usually between 0, which is a poor value, and 100, which is a really good value for your rock. So we'll click on that. And we get this window. In this window, we have different tabs up here. And these are used to compute the rock mass rating value, which is obtained from the 6 qualities that you see here. Recovery index value, joint spacings, fracture condition, groundwater condition, criteria for fracture and orientation in relation to site stability, and then we get the actual value at the end. So we need to, there's 2 ways of doing this. We can put the values as we're taking a look at a rock or at the core. Or if we know the value itself, we can just type it in. If we type it in, all of this become blocked. You can't put in the value anymore. But we're gonna do it manually. So we'll give some values for the rock resistance. We'll also pick a value for the modified recovery index value, joint spacing, the fracture conditioning, groundwater condition, and fracture orientation in relation to site stability. So we'll pick favorable. So now we have a value of 60, which is a regular quality rock massif. And now we want to put that value into the rock that we're observing. So first of all, I need to pick the location of where I'm going to put the block with that value. So I click here. And I'm doing the observation for this section of my drift. So I'll put my block over here. And now I have two options of how I want to display that data. I can put a hatch on my drift, and I can insert a table so that I know what it means, what that number means. You don't need to add a hatch, but I'll add it for this case. This one here, create surface. This one applies to a drawing where you have a surface such as in a 3D drawing. In this case, it's not 3D, so we don't get to use that. You can pick your destination layer. I'll leave it at that. And you can put the date when you did the work. So I'll click OK. Now the program is asking me to select the polyline of the outer border. That's this one. And select the limit lines and or the island. This will be my limit line because I'm only putting the hatch for this section. So I'll pick on that. And then I click enter. And as you can see, the value of 60 has been placed here. And now, because I picked to add a hatch, I need to pick a point inside the boundary, which is here. And then I click enter. If I wanted to go and create more hatches, let's say I wanted to go into this one, I can click on yes, but I'm going to say no for now. And our table comes up. And now we can see what the type of what rock type we have, the class of the rock, and the description, which is regular quality, and the RMR. Now, the values for this can be edited in the options of the module. If we come over here to the options, this is where you go ahead and change it according to the place where you work, the mine you're working at. See, you can change the values and the color for that. You can add more divisions, not just the ones that we have here at ProMine. And you can make a few other changes for the effective radius. This is more applicable to the first couple of commands that I showed you. And the RMR and Q-System rock quality classes, you can also change them here. These are the values we have, the ones you're seeing here at the table. Obviously, you'd have your own, or you change them to the way you like them. For the Q system that we're going to look at in a few minutes, this is where you change it as well. You can also change the type of numbering that you're going to be using. You can use Roman or Arabic numbers. Same thing for the Q system. So we'll click OK, and we'll click OK on that. Now, the next command is if you wanted to go back and edit your RMR values. So if you click on that, you can go and click on your value, click enter, and we come back to that window where we enter our values. And maybe there's a few things change. So now you can see that the value has changed, but I'll make a few more changes. Okay. And we'll click OK. Okay. Good. Okay, I think we're good. Okay, so click OK. I wanted to change color, so click OK, And voila, you can see that the value has changed as well as the hatch. Okay. If you wanted to export this data into a database, you can do it now. This is a new command. And you can do it using this icon down here. Obviously, for this, you will need a database. I've gone ahead and created one where we have our coordinates, elevation, or Q value, RMR value, the date when you can process the data, and the type of rock you have. So to export that data, you just click on the icon. And the program is going to ask you which data do you want to export. I can do the RMR. This is our RMR with the hatches. I'm not clicking on surfaces because I don't have any surfaces. And I also want to export the block data. So this data here, this is the block and this is the hatch. So I'll click OK. So then I select my block and my hatch. As you can see, it's found the two of them. Click Enter. And now it should appear on my database. I'll open it again. And there we go. It's 24 right there. And 2024. So that's the new data. And it's the same thing if you wanted to export the data from your Q values, your Q system. And that's the next thing we're going to look at, the Q system. So I'm switching drawings. This one has, as you can see, it's like a 3D one. So in one like this, we'll be able to apply the surfaces option. I'm going back to plan view. And I'll run the command, Q system. So that just as a refresher, the Q system is going to express the quality of the rock mass in the Q value table. So first of all, you need to enter your sample length. We'll make it simple and we'll just say 100 centimeters. And then you need to enter a sample the length of a sample piece. We'll do 35. And we'll compute the RQD. Okay. So RQD of 35 is bad. Okay. But that's not important at the moment. And just like in the previous command, you also have your tabs up here that you need to complete. So we'll do that. The diaclosation index, we'll just pick any. The roughness index of discontinuities. We'll pick polish and discontinuous. The fracture alteration index, we will pick down here. Rock intensely alter or decompose. Reduction factor due to the presence of water. We'll pick this one. And the rock stress condition. We'll do high stresses. Okay, just like the previous command, we need to select our block location. We'll do this one. Let's say that we're working on this section. In this case, we can create a surface. And we can also add the table. So we'll click OK. Okay, give me 1 second. Why? I think I picked the wrong value. Yeah, someplace I picked the wrong value. Okay. Okay, so it's good now. Okay, just like the previous command, we need to select a polyline for the outer border. So we'll do that. And we have a little bug in this. Let's try that again. Okay. Apologize about that. I don't know why it is that. Let's do 45, compute. Okay. And insert table. We select our polyline. Good. Okay, I didn't do it this time. So I apologize about that. And now, just like before, we select our limit line, which will be this white one, and this one over here. And then we click enter. Our block has been placed. And now we need to click inside the boundaries. And there we go. Now we click enter. If we wanted to continue editing for the other hatches, the other sections, we'll click yes, but I'm going to click on no so we can get the table. And just like the previous command, there's our table. And as you can see, it's a surface this time. It's not just a hatch. And just like for the RMR, there's also a command to edit the key value. So we can go there, select our object, click enter, and then we can go and change it. This time I'm going to do it manually. So okay. Let's try something high, like 400. And there you go. Now it changed the block and it changed the hatch on the surface. And that's basically what this command does. Sorry, what this module does. Now, I would like to know if anyone has any questions regarding the module. As I mentioned, it's a very small module, only 6 to 8 commands, really small option section. But as I mentioned, it's a useful tool to compute the hydraulic radiuses in your mine. Also, to compute the RMR, and the Q values of your rock. So if there are no questions, I want to thank you for attending this webinar. If you'd like to get any more information regarding the module or anything ProMind related, please don't hesitate to contact us. Here's the email address, support@promind.com, or you can find us in all the social media platforms. I want to thank you again for joining me today. Thank you for your time, and I wish you all a happy day. Have a good day. Bye.